Good Monday morning! Today we're going to do a little continuation on last week's video, which was about doing dependency injection in JavaScript without using classes. I am MPJ and you are watching Fun Function.
That is your computer, your friend. It is your learning.
I am back at home and it feels so good. If you're wondering about my hair, this is my stage hair from Nordic.js. Do you like it? Which I have been co-hosting last week, and it has been this week because I'm recording this on Sundays, and it was amazing, but it was also probably one of the hardest pieces of work I have ever done. Jesus, it was so intense. Some fans showed up and gave me Serbian candy. I suppose it's not a good idea to eat stuff from random people on the internet, but it's pre-packaged, so I think it's fine. If I die, this will be proof. This is from Nemanja. Thank you, Nemanja. At least I'm pretty sure it was Nemanja. And things were pretty hectic at Nordic.js. Oh my god, this is very good. Oh. Anyway, last week we explored how to do dependency injection without using classes in JavaScript. And today I would like to continue exploring this, but with some more sophisticated examples. And also discuss a little bit about architecture. Here is the example that was in the beginning of last week's video. Just to very quickly remind you, this was a class, a user manager. It takes a database connection. We inject that here in the constructor, and then there's a create user method which uses this connection to access the table users and insert a new user with some bullshit properties that I made up. And then it returns the user ID. Exactly what this code does is not important. The important part is that it's dependent on this database connection, and we want to inject that so that we have control over our dependencies and we can test them. And then we refactored this code to, instead of using a class, using a set of nested functions. And we export it. Okay, so this does exactly the same thing by having this creating this factory function which creates the make user function and uses a closure to pass the connection dependency instead of using class properties. So that is what we did. But what I would like to discuss today is, if I just Ctrl-Z back to our original example there. What if we had more than one method here? Let's say we just invent one, delete user, and we call it needs an ID. There. And let's just make up some implementation. Alright, so now the situation has changed a little bit, because we now have both these methods are now making use of this dependency. So we are sharing the injected dependency between these two methods. And this represents what we are going to explore today, this sharing of dependencies between functions. I'm going to show you how to do this without using classes, but I'm also going to discuss a little bit about why you wouldn't want to do this kind of sharing. What are the caveats with it? Like, when should you do it and when shouldn't you? increase the font size a little bit. All right, let's go back to the functional example here. Bloop, 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 bloop. This is the same one as before. And let's add a the delete user equivalent. Delete user, and it was a connection and a name, and it was something like this. Oh, it was an ID. Right, something like that. This exact implementation is not at all important. What we are concerned with is this relationship here. Okay, so let's think about how we use these things. This is the example from the last episode. This is the file that we were just editing, and we are pulling in make create user because that already existed there. Now let's also pull in make delete user that we had. And then we will use make delete user to create the actual make delete function. Const delete user, make delete user connection. All right, so what we see here is a little bit of duplication that will disturb your eye a little, because as programmers we are trained to look for duplication and remove it. I often talk about how you should be very careful about removing duplication. You should absolutely do it, but you should do it defensively and wait for a lot of duplication to arise before removing it, because otherwise you will probably misidentify the actual pattern and you will generalize incorrectly. We will be talking about this during the course of this video in many examples. But for now, let's imagine that we actually want to remove this duplication. Let's imagine that we have some more examples of this. Let's say that perhaps we had, let's say that we had make update user and perhaps make ban user as well.
And we can do those here, update user and make.
So now we are starting to see some duplication here. We are going to be removing this, but first I would like to draw your attention to the fact like this dependency is very easy to see now. Like it's very clear how the dependencies flow in the app at the moment. There's some duplication, sure, but it's still very easy to see and reason about. It's very simple. But let's play around a little bit with some higher order functions. If higher order functions is a bit fuzzy concept to you, I have a video on that there that you might want to check out. Bam! So this is exactly the same. So you see here that this thing here, we have replaced that with by using a map here. So basically we have taken all of these here, put them in this array, which is called factories, and then we map over the factories here, and for every factory we call that factory with the connection object, and that will give us an array, and then we use destructuring here to extract that into variables. So now we can just call like create user and Joe Smith here, or delete user 1, 2, 3, 4. If this syntax here is new to you, this is called destructuring. It's a new feature in JavaScript. You can check out my video on destructuring here. This is pretty cool, but we are doing way too much prediction of the future here. We are assuming that all functions will have the same set of dependencies, which is not true. Let's say that ban user also required an email service. So yeah, we could inject all of the dependencies into all of the functions. This becomes a little bit weird. It's not completely unreasonable. I guess that we could just inject all dependencies as an object into all, inject all dependencies into all factories. But seems to me that we kind of want a little bit more control. This seems... let's try another way. Okay, so we know that this wants an email service as well. I'm not gonna write email service out. You can imagine that it's just the same thing as this connection, but instead of Unicorn DB vendor, perhaps it's some email service vendor, and we do some instantiation here and then pass it into ban user. Okay, how do we proceed here? All right, so instead of these, imagine that we had a make user utils function, and you call that make user utils. You know what? I'm gonna comment this out to leave it for comparison. And we're going to pass in the dependencies, connection, email service, and that is going to give us an object that we will destructure.
Into these.
Let's go back into user utils and have a look. Wow, I see that I actually made a mistake here, a confusing mistake. It should be make delete user here, because this is a factory that creates the delete user. Delete user is this function here, and this whole thing here, that is make delete user, or this, you can think of it as the thing creating the delete function delete user function. Anyway, let's refactor this a bit. We want to export default const, and we want make user utils. And oh, we can't export a const, hang on. We have to do this first. Make user utils, and utils, and that takes an object with dependencies, and those dependencies are connection and mail service, I think it was called. And that will just return an object. There we go. And these are no longer our factories. These are the actual functions, because they now have access to the connection object here. And I'm gonna do the same thing with delete user. Hang on. And colon instead there. Delete that and export default make user utils. So we're exporting that. Oh, indentation should be right. So now we are making this, like, instead of having a factory oops for every function, we now have this sort of like wrapping factory for all of them at the same time, so that they share the scope, the closure scope here, so that both these functions here have access to the connection object. So this way we can also create the ban user function. I guess it takes an ID, and then there's a connection dot table users. Let's call it update something. Hang on, and maybe that takes a delta. So let's say that it's another MongoDB syntax here, something like band true. I don't know, I'm making this up as I go. And when the update is done, it should call the mail service. We don't have the email yet here, that we would have to figure that out in another way. That's not really relevant to the example. Let's just say joesmith.com and I banned you, lul, busted operator from hell. Alright, so you see here now that this has access to the mail service, this has access to, these have access to the connection. And if we go back, remember how it was used, we just pass in the dependencies here as an object literal, and it can access them, and then it creates all of these in one fell swoop for us. Notice that this pattern is very similar to a class with some constructors. Let me just drop up the class, sort of. So here we would just have, let's say, mail service, and we would go this dot mail service equals mail service, something like that. And then we would do the same implementation here, but instead of using the closure of the function like it did here, it would use the these properties on the instance instead. But essentially the two patterns are very similar. It's just that this uses just functions and closures instead of the class construct. A problem with this pattern is that we are oversharing. So mail service, it's very nice in this case when connection is used by all user utils here, but mail service is only used by a few. So that means that this mail service here is being exposed to and passed into to both create user and delete user, even though they have no business knowing about that. This is not exactly a cardinal sin, but it can be problematic, partially because the dependencies are now less obvious. For example, before we could look at, in this case here, if we go back to the app, here we can see exactly what dependencies each thing has, but here this has now become slightly more obscured from us. Dependencies are starting to become this blob of things. Also, even if you look in the class, the whole dependencies chain is a bit... When you see something like this with a group here, it kind of makes a person that starts working in this class, or this, whatever we call it, module, it makes them think it's okay to use the mail service, which it might really not be. Like this is just its own thing here. Like just because something is in this utils file doesn't mean that it's sensible to start accessing the mail service. So this grouping here is starting to become a little bit problematic. Speaking of the grouping becoming problematic, it also becomes problematic in another way. It's that user utils, like, it was just something that we started doing because when we had a create user, we put that in some file or some class, and we just figured that that file or that class, it needed a name, and then it became user utils, and it felt like, okay, this is the place where we put CRUD operations for users. But once we start actually doing things, we realize that, hey, we actually need functions that do quite a bit of things, so such as mailing users, or perhaps if we are deleting users, perhaps then we need to do something with payment information or billing information or whatever. We're not quite sure what this this group of things is, because we have created the group prematurely before we actually know where we were going. It would have been better to just have kept all of these functions like isolated and let them live their own lives and let a pattern emerge before starting to group them, because when you start grouping things, it becomes harder to unentangle them, and it also communicates something to other programmers that, oh, this is a cohesive group, but it's really not. It's just starting to get grouped by what dependencies they have, which is not really a good and sensible way of grouping things, to be honest. Like, you want to group things in a... Like, there are many other much better ways, cohesive ways to group things than what they depend on. But it becomes a consequence if this is what we do, breaking things into modules based on their dependency set. I want to really drive this home. Let's go back to the class example here. When we created create user here, and we had to create a class. Let's imagine that we were in a language like Java, where everything is required to be a class. Then whenever you create a function, you also need to create a wrapping class. And this creates an interesting problem, because we know what we want to do. We know that we want to insert a user into the database, and we decide that create user is a sensible name to do that. However, Java would also force us to name this thing, this class, this group of one. And there's a subtle, sinister thing about that. And it's that partly it's distracting, because we have to name one other thing, and naming is hard and time consuming. There's an old joke in computer programming saying that, what is it now? There are only two hard problems in computer science, concurrency and naming things. Like, naming things, hard, takes time. And here you're forced to do that, even though it's not really required. We just wanted to create a function. And also with the naming, the reason why naming is so hard is that it requires you to predict the future. It requires you to think about what will come next here. And because you really have no information, you have just one piece of data or just perhaps a few, it's just too early for you to make that decision. It's not sensible to do that this early. You should wait for more duplication and instances of something to arise before generalizing or starting grouping and organizing. In order to group and generalize or whatever, you need to see a pattern. You need to know what the general pattern is. And if you don't let duplication arise first, you are going to invent too much of the pattern in your head, and you are going to predict the future incorrectly. Or not going to, but probably you're going to be wrong. And since this is something that we do a lot, we should rely on probability. This is actually a great example of one of the main reasons why I dislike object-oriented programming. I feel that it incentivizes you to predict the future at an earlier point than you are able to do it well. What we do here, like making these user utils, in a real app, this is not what I would do. at the moment when I'm programming. The reason why we ended up with user utils was that I wanted to create something that had a good one-to-one mapping with the initial class example. In a real app, I would actually do something like this. Something, I don't know, other services or something. And then I would like just do something like this. And then I would import them from there. Oh no, sorry, like it would be make create user and make delete user and make update user and make ban user. And then I would just have this, this huge file. Well, let me go back here to where we were before. Like this. And the file would look like this. And I would just dump shit into this other category until I started figuring out very clear patterns on organization. And then, and only then, I would start creating something like would be like, oh, I don't know, account services or something, where I start putting things like the user flow things, or I don't know, like, that's the point. I don't know. You don't know how an application will be structured, or what structure makes sense for an application until you are quite a bit of time into it. So I'm a big fan of programming your architecture defensively so that you can let structure emerge as the patterns emerge and become clear to you. I have tried so many times to do upfront architecture in an application, and it has literally never worked. It never works because humans are not particularly good at predicting the future. Our brains are wired to they are designed to plan movement. We're designed to okay, if I walk behind that rock, then perhaps there's a lion. I need to watch before the lion. Our brains are basically for planning movements, and predicting the architecture of a software application, that is way too complicated for our brains. So let duplication arise in high quantity if possible, instead of trying to predict what that pattern will be. And that is what I wanted to talk about today. I wanted to show you how you can share dependencies between functions when you are doing dependency injection without classes. But I also wanted to talk about the problem with sharing dependencies in general, and how you should try to wait for patterns to emerge and be clear instead of trying to predict the future up front. You have just watched an episode of Fun Function. I release these every Monday morning, 0800 GMT. You can check out another episode here. If you have questions, thoughts around this episode, you can check out this topic on the Fun forum that is dedicated to this episode. I am MPJ. Until next Monday morning, stay curious.